This video is all about cryosphere. I will be covering following topics in this video: introduction to cryosphere, its role, why there is need to study cryosphere, how we can study it, and then processes related to cryosphere like ocean currents and Arctic amplification. So, what is cryosphere? Cryosphere is that part of the earth where water exists in solid form. So where there is snow or ice, that part is of cryosphere. Cryosphere not only include North Arctic and South Antarctic regions only, but also places between them. Like we can see in this picture, pink color showing glaciers over all continents except Australia. In South America, Andes Mountain consists of number of glaciers like Perito Moreno Glacier, Southern and Northern Patagonian icefields, and others. Over North America, there are number of glaciers across USA, Canada, and Alaska. Like Wheeler Peak Glacier is there, South Cascade Glacier is there, and in Europe, Elec Glacier is there. Even in Africa, there are glaciers on Mount Kilimanjaro and Mount Kenya. In Asia also, number of glaciers are there, like across Tibetan Plateau, which is popularly known as Water Tower of Asia. And in India, Siachen Glacier is there, Gangotri Glacier is there, and many others. So, all these are part of cryosphere. And this cryosphere is not stable. It varies season to season and year to year, as snow and ice go through cycles of growth and melt. Role of cryosphere. Due to presence of cryosphere, Earth's albedo is 0.30. That is 30% of incoming solar radiations are directly reflected back to space, which helps in keeping our Earth planet cool. With it, cryosphere also influences ocean currents, weather, climate, and sea level. It has massive amount of stored carbon, which is double of that contained in the atmosphere. Why we should study cryosphere? Because it is an indicator of climate change. It not just tells us about past climate, but also give us some clues about what could occur in the future. So, how we can study cryosphere? Answer is ice cores. You can get an idea about ice cores by looking at this animation. Ice cores are perfect recorders of past environment. Inside ice cores, environment is trapped about thousands of years ago. From thousands of years, polar regions get snow every year, which do not melt. So, we get 1 year snow on top the next year snow. It compresses, and everything that fell on snow, either dust or salt from ocean or volcanic ash or pollens or air bubbles with atmospheric gaseous composition, everything is preserved in ice sheets from millions of years. Scientists drill these ice sheets to get ice cores. Like we can see in this picture, this is ice core. Layers in ice cores are like tree rings. Each layer represents a year of weather and snow. By studying these ice cores, we can tell past temperature, how dustier the atmosphere was. We can also measure variety of gases that were in the atmosphere by studying air bubbles which are trapped in these ice core layers. So this is how we can study cryosphere. And by studying these ice cores, scientists have created this graph showing carbon dioxide concentration in the atmosphere from past 8 lakh years. This dotted line shows that from millions of years, carbon dioxide concentration had never been above 300 ppm. But from 1950s, it is. And this is what scientists have formulated by studying ice cores. Then the processes related to ice core, processes related to cryosphere, ocean currents, and Arctic amplification. First, let's see how cryosphere is responsible for ocean currents. Ocean currents fall in two categories: surface ocean currents and deep ocean currents. Surface ocean currents control motion of top 10% ocean water, whereas deep ocean currents mobilizes the other 90%. Both have different causes but influence each other that keeps the entire ocean moving. First, surface currents. In open ocean, wind is the major driving force for surface currents. As wind blows, it drags top layer of water along with it. If we zoom out to look at the pattern of surface currents all over the earth, we will see that they form big loops called gyres, which travel clockwise in north hemisphere and anti-clockwise in southern hemisphere. And this is because of earth's rotation that deflect air eastward and westward. This phenomena is known as Coriolis effect. These surface currents helps in distribution of warmth around the globe. Now comes the deep ocean currents. When extremely cold salty water is pushed out of newly formed ice crystals, it forms brine icicles. These brine icicles are cold, denser than surrounding water, so they travel down towards the ocean bed. And in their way down, they freeze surrounding water and make it more denser, so this water sinks. And as surface water sinks, it leaves room for water below to rise to the surface, which causes upwelling. And this initiates deep ocean currents opposite to surface currents. Combination of surface currents and deep ocean currents form a winding loop called global conveyor belt. Then comes the next process, that is Arctic amplification. Arctic amplification means Arctic is warming twice as fast as the rest of the world, as shown in this figure. And this warming is because carbon dioxide and other greenhouse gases are increasing from industrial era. That is, carbon dioxide concentration in 1800 was around 280 ppm, and now it is almost double, that is 415 ppm. Due to this, temperature of globe is increasing and Arctic sea ice is reducing. That we can see in this animation. Ice pulses out and in with the seasons. In winters, ice grows out, and in summers it contracts inward as it melts. We can see older ice moving around by winds and currents, but eventually it is moving out of the Arctic into the North Atlantic, where it melts. In the past, there was enough ice surviving the summers to replenish older ice that lost, but in recent years there is less replenishment. Ice that is going out not been compensated by ice growth. Older ice disappeared and Arctic is now dominated by younger and thinner ice. We can also explain these changes in Arctic sea ice by positive feedback loop, that is Ice-albedo feedback, which is a vicious circle amplifying the changes. Like when surface warms, ice melts, and this melting ice releases stored carbon and also expose darker surface to sunlight. Both these changes due to melting of ice absorb more heat, and there is even more melting, so this system can feed itself, hence positive feedback loop. Scientists have predicted that Arctic will be ice free before 2050. Now just imagine how Earth will keep its coolness and how ocean currents will go on without ice. By our daily activities, we are releasing around 35 billion tons per year of carbon dioxide in the atmosphere, and hence global temperature, ocean acidification, ice melting is increasing. Eventually, climate is changing, and we are witnessing it. Thank you.